Okay, I'm back on Zoom, my home turf. Thank goodness. Oh my God. Google was a nightmare. All right, so I'm going to quickly just show you the key, just so you have it, a nice screen. You can pause it. So, because I was holding up things and all right, so let's quickly go through. Let me share the screen, and this is for take-home test. This is for take-home test 1B. This is fall of 2022. Let me share the screen. I mean, come on. I thought Google was supposed to be cool, but that wasn't cool at all. All right, so there you can see the screen. That is 16. I got to be quick because Zoom will cut me off here pretty soon. That's 16. Things to talk about this. I would, since you're take the time to late night watch this or early in the morning watch this, I'll give you some Easter eggs. There will be one like this. I'm working on it right now on the test. It's similar, but yeah. So there will be one if I can get the thing to squeeze the fit in there. I won't know till about 2 in the morning, but I think this will get on the test tomorrow. One like this. Okay, heads up. As far as so the orange part is just looking at what's happening in the X. So you put your orange goggles for that orange graph. You put on your blue goggles for the blue graph. Okay, everything happening north south is blue. Everything happening east west is orange, yellowish orange there. And that's what I'm trying to get you to see, is to separate, to become bipolar in your X and Y. Okay, let's keep going. Just how you represent in and out. 17, this one, I already told the crew on the Google Meet that this would not be, one like this would not be in the test, mainly because I screwed up the boxes. That's the first time I've ever shown this question. And I screwed up the boxes on because it's a profile view. Originally, I had it as a map view. Then I changed it at the last minute to a profile view, and I forgot to change the boxes. I'm talking about these boxes right here. That should just be one box, where you'd put below left horizontal. So that would be south of west. But because it's a profile, look at the side view, that's below left horizontal. Notice that's a K roof on there because that's the Z axis. Now, if you made that J roof, I wouldn't count off. I wouldn't count off. But anyway, that's not going to be on there. 18, there will be something like 18 on there. I'm still working on that problem as well. I don't even know if we even looked at 18 now that I think about it. Anyway, so 18, Ghost Dog Pepper is walking around. You have to write the displacement. You have to show the displacement vector. So I just, now to get that purple, to get this part, the purple part here, I had to, I used, okay, it says she goes 50 meters, 30 degrees north of east. So you could use a protractor to measure the 30 degrees here. Okay. And then, or you could use trig, but who's going to use trig, right? So we're not quite too good at that yet. And then she goes 50 meters. So I measured this. I measured 50 meters with a piece of paper, and then came up, measured with the protractor 30 degrees. That's 30 degrees right there. That's 30 degrees. And then just drew my vector. LOA means line of action. Don't worry about it. Let's just get rid of that. You don't need that. Forget that. Okay, and then the displacement vector goes from the very beginning to the very end. So it goes from the where she started to where she ends. Okay. Now you have to describe that displacement vector, and you describe it in the component method, negative 20 meters I roof, minus 45 meters J roof. Okay. But you can also describe it by giving the length and the angle. So you got to find theta here. And you can use a protractor to find theta. So I said 49 meters, and that's just measuring it I think what I did was I used trig, I guess, to find the, because I used Pythagorean's theorem. That's 20. That guy is 20. That guy's 45. So Pythagorean theorem, square, square, take the square root of the sum, and that gives me 49 to 2 siggies. Meters, 66 degrees. That's with, that could use an inverse tangent. I think is what I did, but you could use a protractor, and I'll take plus or minus 3 or 4 or 5 degrees, let's say there. And then south of west, so south of west. Okay, always do it from the east-west. Number 19, let's blow this up a little bit. The first one is just, the only way to do it is to subtract. That's a small, 5 plus 12 cannot ever, ever, ever equal 6. It can equal 7 if you subtract the 5 from the 12. 5 plus 12 equals 13. That's true if it's a right triangle. You know, 5, 12, 13 right triangle. It's Pythagorean. It's a Pythagorean trio. Okay. So it has to be head to tail. Notice this is head to tail here. This part is head to tail. And then the resultant, I always make the resultant in red. It starts at the very beginning, goes to the very end. There's only 2 vectors. But I could have 7 vectors. The resultant still goes to the very beginning to the very end. Okay. And that is 13 units long. And then we get 5 plus 12 equals 15. Well, I'll take an obtuse, as long as you give me an obtuse triangle. I'm not going to be all detailed and is that the exact right spot, those kind of things. If I see an obtuse triangle on one like this, and I haven't written this problem yet, but I think there will be one of these on there. It'll either be an acute or obtuse triangle. I'm happy with that. I mean, you know, so don't get the compass out. But anyway, 5 plus, so there's 12 plus 5. We add head to tail, gives me a resultant vector of 15. Okay, now we get to this one, and nobody had a question on this, which I thought was strange. But this comes from sheet 1.8, which I kind of purposefully avoided it this year because last year it was such a mess. We spent like 2-3 days on it, and oh my gosh. And that way whenever we do that, we lose time on other things. And so I kind of just sort of give it a little bit of love here, at least to show it. But it's 2-dimensional motion as well. I'm kind of, I'll tell you the truth, I'm opting, another Easter egg here, I'm opting more for this kind of 2-dimensional motion rather than this kind of 2-dimensional motion. So Ixnay on 20 as seeing that one on the test. Ixnay on that. Probably the one. I haven't written it yet, but well, if I tell you now, I guess I got to do it. So I wouldn't worry about this one. But what it's showing you is that you're going at this angle, and so you're going in the X and you're going in the Y at the same time. And you went 50 meters in the X, or sorry, this is X and Z. Another reason why I'm not going to have this problem on the test. And I can make, look, I can make the, I can make these axes anything I want, X, Y, Z, right? So I could choose X and Z. I could choose Y and Z. I could choose X and Y. It's whatever whatever you, whenever you're doing your experiment, want to call it. It needs to be X, Y, or Z. But anyway, somebody asked, should I make that, should I put an I roof there? And certainly you can do that. And that would be a K roof there. That's a nice touch and would probably get you a bonus point on the test. If there's an I and J in the problem here, then there has to be an I roof, J roof, or K roof in your answer, okay? It wasn't in the problem, so you don't need it in the answer, but it's a nice touch. Okay. And then over here on these, we went 50 meters, and so it shows me in the X. Let's look at the Z first. I went 50 meters. There's my 50 meters. See, 50 meters. But this is a duration. It took me 10 seconds to do that. And it says right here 10. It says up here 10 seconds. So 50 meters at 10 seconds, my slope must be 5 meters a second. Here, negative 30 meters in 10 seconds, my slope must be negative 3 meters a second. Okay. Don't worry about this problem. let's go to 21. 21 certainly could be on there. I would study this one. It's our pinwheel outside. And we had some really good questions in the Google Meet about why is omega negative. And omega is negative because you're going clockwise. The other good question was from Coach. He asked, why are these like that? What are these? What's going on? And these represent, I should put a, look, they are all congruent. Because we were supposed to go, these are supposed to be congruent. I didn't do a very good job. But we're supposed to go at the same pace the whole time. These are the same speed, they're not the same velocity because they're different directions. Velocities are tangential. So I guess I was throwing that in there just for fun, but do you have to draw these tangential vectors? No. I'm not going to ask you to do that. This stuff is fairly new, so I'll go easy on it because things that are new, like in a 2 or 3 days old, I try not to either don't have it on the test, or if it is on the test, try and make it more obvious, like a lot like the take home. Okay, so anyway, determine your omega. So omega is delta theta over 2. We went 90 degrees, negative pi over 2 because we're going clockwise, and we did that in 16 seconds, and so it ends up being negative pi over 32, or you can leave it, we're supposed to leave things. We're not supposed to leave things in terms of fractions. There's a little bit of exception on that on circular world, but if you're going to get persnickety about it, then yeah, let's go ahead and make it 0.031 pi. Okay. Now I'm freaked out that I'm going to lose, that it's going to cut me off at any minute. Very stressful night here. And then we're doing a little bridge to find the speed. I said velocity. I changed it to speed, and on yours, I'm not sure if I changed that on yours, but just to be more precise, I think that's why I made it speed, so that we wouldn't have that controversy here on that negative. But we had this discussion in the Google Meet, but I'll take plus or minus there. Velocity, it's questionable whether it's positive or negative, because I guess you could say, well, it's going up there and it's going to the right there, so it must be I just said the lights went out. I guess I'm still good. It must be positive because it's up and to the right, so that's always positive, assuming. Anyway, I made it negative because the omega was negative, but if you just say speed, that's absolute value, and then 3.14 feet per second. Notice you don't say pi because it's linear world again, so you only use pi in terms of circular world. Okay, 22 is, there it is. You can certainly pause and look at that. That is going 2/3 the way around. So for omega's terms, that's 2/3 times 2 pi, because all the way around is 2 pi radians. So 2/3, which makes it 4 pi over 3. Okay, that's how far I went. And then the time it took me to do it was, omega is going to be 0.05 radians per second. So magic triangle, if I'm trying to solve for time, that's delta theta over omega. So I have 4 pi over 3 over 0.05, and that gives me 83.7 seconds, and I convert that to minutes, so 1.4 minutes. Nobody had a question on that one, so let's keep going. 23 is about the easiest problem on the test, as long as you know the little bridge, and the little bridge is on the reference sheets. So V equals omega R, omega then is V over R, simply divide it, and we get 2. Thing is, you get 2 radians per second, so 2 inverse seconds. If you wrote the word radians, I wouldn't care. Radians per second is fine. And then you got to show it. So that's you showing it right there. Okay, it's not, for some reason, it's not. There it is. Okay, so that is your omega vector. It's at the axis of rotation coming at you. So I make it a dot. 24, I'm worried about time, so I'm going to skip it. It's not on this test. We'll talk about it in packet 2. 25, finally we get 25. That one is me following a plane, a 747 above my head. I just sit in the campsite, I remember doing this, and I know the speed of 747 is about 550 miles an hour. So I thought, I could determine how high that is just by finding the omega. And I thought I was very proud of myself. So I did that, and I kind of I went about a 45 degrees, It's not hard to figure out. 45 degrees, which is pi over 4 radians. And then I just used my magic triangle to solve for R, and that's V over omega. I had to do a little bit of unit analysis because I had to convert that seconds into hours. No, I'm sorry, I had to cancel hours, so I did need to convert seconds into hours. And that green kill pin killed everything except the miles, which I need. That's my radius, and I got 8.7 miles. Okay. All right, didn't cut me off. Let's go back to stop sharing. And yeah, see how easy it is. Sorry, Google Meet. Zoom wins. You suck, Google Meet, as far as I'm concerned. All right, so I will now, I'm going to end this and record it and put it on YouTube. Okay, without further ado. See you guys tomorrow. Get everything together, get your notebook together, get your packet together. So when you walk in the door, you throw that pack, you drop that pack in the box, you put your notebook in front of the box, boom, you're ready to go. As soon as you're ready to go, I give you the test. It's bell to bell. All right. Bring a calculator. Make sure your calculator is in degrees. I know we're talking radians, but your calculator needs to be in degrees. Okay. Sorry, that's physics is weird. That's how you got to do it. And then what else? Bring some colored pencils. Maybe I have some, but it's nice. You always get a little bonus for coloring some stuff. I like to see colors. Pencil. Don't bring a blue or black pen, or you can don't bring a pencil. Okay. I think that's it. All right, I'm going to record this. I'm going to put this on YouTube. Pause. Okay, it's paused. Okay. End.